you guys doing there? I guess you're going to go ahead and get started without me, huh? Alright. Well, here I am, ready to go. Let's talk about graphing, line of best fit, and calculating slope. Sorry, being silly there. Okay, yeah, so let's do this. We're going to talk about graphing. We're going to talk about how you come up with the line of best fit and how you calculate the slope. This is kind of the end of our scientific method stuff. So we're going to kind of use some of that scientific method stuff and kind of add on to it. All right, so let's go. So here we have an example of an experiment. We'll use the data from this experiment to come up with our graph, and then we'll add our line of best fit and we'll calculate the slope. But let's go back and look at the experiment and come up with our title and hypothesis and all that other stuff. All right. So Anne decided to test the effects of varying concentrations of vinegar on the height of her bean plants. She used different concentrations of vinegar and recorded her bean plant height after 5 weeks. The height is recorded in centimeters. Now, we need to come up with a title and hypothesis, but when we look at the title, remember our title has to be the effect of the independent variable on the dependent variable. So maybe it might be easier if we come up with our independent and dependent variable first, and then we can do our title. All right? So remember the independent variable, that is what the person doing the experiment has control over. So what does Anne have control over? Well, let's look and see. Maybe she has control over the concentration of vinegar. All right? The dependent variable, remember, that's what are we trying to find out? We are trying to find out how high the plants are going to grow based upon the concentration of vinegar. So let's come up with our title. Maybe something like the effect of vinegar concentration on the bean plant growth. Of course, when we need a hypothesis, and of course you do the hypothesis, or I'm sorry, you would come up with your hypothesis before you would actually do the experiment. And if we look at this, we might say something about if I do this, or more importantly, if Anne does this, then that will happen. Remember, after the then is your prediction, okay? What comes after if is what your independent variable is. So maybe a hypothesis might look something like this. If Anne uses a higher concentration of vinegar, then the bean plants will have a lower growth height. How about a control? Remember, the control is what we're using to make a comparison to. Sometimes we say it's what would be the normal one or the normal thing. Well, normally you wouldn't have any vinegar with your plants, so the zero concentration of vinegar might be the control. And then our constants, remember when we do an experiment, everything has to be the same except for what you're testing, except for the variable that you're testing. Okay, so the variable that we're testing is the concentration of vinegar, so everything else has to be the same. So here are 3 examples. The type of plants, you wouldn't use one bean plant and then use another species of bean plant. You'd have to use all the same bean plants. The time of the experiment, you wouldn't test it for 5 weeks for one set of plants and then test another set of plants for 7 weeks. And the unit of measurement, she said here at the top, she's measuring everything in centimeters. You wouldn't measure something in centimeters and then another one in inches. That wouldn't make any sense because then you'd have to do some calculations there and just make more work for you. All right, so that's kind of a review of that stuff. What we're more focused on is our data here. Okay, so we had 10 plants for each concentration. We come up with our averages. The averages are what we're going to graph. It'd be a real pain to graph all of these pieces of data here. So that's why we go ahead and graph the averages. And of course, to calculate the average, you add them up and divide by 10, since there's 10 plants, and you come up with these numbers. Now I rounded these to the nearest whole number. It makes it nice and easy for us to graph. Okay, so let's look at our graph. So when we're ready to do a graph, of course, every graph has to have a title. We can just use the title straight from the actual experiment. Okay, remember our x-axis is our independent variable and the y-axis is our dependent variable. And probably most importantly when it comes to creating a graph, your increments, for lack of better words, all right, how you're going to plot the data has to be the same. And what I mean by that, let's take the x-axis for example. We have 0, of course, on the corner, and then I use 1, 2, 3 little boxes to go to 10, okay? That means I have to use 3 boxes to go to 20, 3 boxes to 30, so on and so forth, right? You wouldn't use 3 boxes to go to 10 and then only go 2 boxes to go to 20. Because if you did that, that would mean that your space in between each section wouldn't be equal, and they have to be equal. Same thing on the y-axis. I go from 0 to 5 in 1 box. That means if I'm going from 5 to 10, that has to be 1 box. So on and so forth. Now this is completely up to you how you want to do it, but the idea is that, remember, a graph is a visual representation of our data. We don't want a little teeny tiny graph. We want it to be nice and big so it's easy to see. Okay? If you wanted to use more space, that's completely fine, but you just have to remember your graph, the data for your graph has to be able to fit on the page, whatever size page you're using. Okay? So this just kind of works out well. All right? Now, of course, the other thing we need to worry about is each axis should have a title. All right? So if I did that here in my x-axis, remember it's our independent variable. So here's my title, vinegar concentration. I also have to have a unit of measurement. So my unit of measurement here is percentage. And then over here on my y-axis, I have plant height, and my unit of measurement, remember, is centimeters. Now, all I have to do is from my data, I plot my points. So at 0%, I had 79, and at 10%, I had, I think it was like 67, and so on and so forth. Okay, I think I had a 44 to 43, and then this I think was 22. Okay, now you guys should all know how to plot points on a graph. If you don't know how to do that, and this is difficult for you, please make sure that you get with me so I can help you with that. All right, if you don't know how to do it, no big deal. Just let me know so I can help you, and we can have some time to do this. Okay, now here comes the fun part. We have to come up with a line of best fit. And you might be saying to yourself, what the heck is that? So a line of best fit is a line that we draw on our graph within our data points to show kind of the general direction of the data points. Okay? That's one of the rules. It has to show the general direction of the data points. All right? So let's do an example. Let's say I drew a line. Let's say I drew this line right here. Now, would that work? Absolutely not. It doesn't show. It's not in the general direction. You can see here's my data points. Obviously, my general direction is going down. Okay, so this doesn't work. So what if I took this and I just kind of moved it? I don't think this allows me to do this. Yeah, it does. All right. What if I just moved it like this? Okay. Would that work? Well, kind of. It kind of shows our general direction, right? Let me move it down a little bit better. It shows our general direction of our points because our points are going down this way. I just almost tried to touch the screen. So it goes down this way. So yes, that would be pretty okay. Rule number 2, though, is that when you draw a line of best fit, you have to have, as best as you can, an equal number of points above the line as you do below the line. Now, do you have to have exact equal points? No, but it has to be something close. You might have, say, 2 points above and 3 points below. Totally fine. What you don't want is something like 1 point above the line and 5 points below the line. Then your line of best fit is not correct. Okay? So let me show you what this should look like. So here's our line of best fit. Whoop, these are supposed to be covered up. So here's our line of best fit here. Okay? So let me show you. 1, it follows the general direction of our data points. And 2, I've got 1 point above. I have 2 points below. It's totally fine. So we're in good shape. Best thing is I've got 2 points right on the line. Now, do you have to have 2 points, 2 of your data points exactly on the line? Not necessarily, but if you can set it up that way, that really helps you out when it comes time to calculate your slope. All right? So this works out really well here. Okay? And again, you might be asking yourself, why in the world am I having to do this? What is the point of this? Well, the point is, if we were to, let's say we wanted to find out what would happen if we had 50%. My dogs are fighting in the background, sorry. What would happen if we had 50% concentration? So we go out 1, 2, 3 more boxes here, and we had a 50% here. Well, this line of best fit would help us predict where we might have a data point on here. Okay? And what if we had to go out to 60%? We could adjust this line down, and we'd kind of be able to predict what those data points might look like. Okay? So that's what helps, how it helps us. Now, the other thing that we have to do is we have to calculate the slope. And this is pretty easy since we have 2 points on the line and we know our x and y for each of those points. So here's our formula for slope. y2 minus y1 equals over x2 minus x1. So we're going to take our 2 y points, subtract them, and divide that by our 2 x points after they're subtracted. Okay? So here I have 1 and I have 2. Alright? So let's look at this. So these are my y's. So 22 is my y2, 66 is my y1, 40 is my x2, 10 is my x1. And when I do the math, I get negative 44 over 30, and of course that gives me negative 1.5. Now you might say, oh my gosh, there's a negative sign. Well, that's completely fine because we have a negative slope here. If we had if it was going to be a positive, then our line would have to go up this direction, right? But since our line is going down, we know it has to have a negative slope. Okay? Now, I know I went through that really quickly, so you probably want to watch this video a couple times, right? But we're going to do a lot of practice with this in class. Probably have some homework to do this, all right? So give it a chance. After a few times, you'll be an expert on it, and it won't be any big deal, all right? So there you have it. If you have questions, make sure you let me know. Otherwise, make sure you watch the video a few times, do the homework, do the work in class. You'll be completely fine, all right? See ya.